Just for now, thank you everybody for coming here. Thank you for the groupie team, and thank you to the million of persons looking us live from the internet. Thank you everybody. Okay, so basically, my objective in this talk is you have heard many times continuous delivery over and over. Somebody have been telling you the theory over and over, and then you actually never got to see a real example. So I want you to go through the history inside our company, how we've been working on this one for years, and what we have, and where are we now, exactly. So to begin with, some introduction about myself and what we do, basically. In our company right now, in the workshop, we have around 500 components. Right now, components, I'm going to be calling everything that has a master or a trunk, depending if you're working on Git or Subversion. So we rely heavily on microservices, basically. So we have a lot of things coming. During my few years working there, well, more than a few, around 7 years, we've done around 16,000 release candidates and more than 500,000 deployments. Basically, what is continuous delivery to us is basically bringing the software to production with minimum interventions and no surprises. The definition of continuous delivery basically is like the software is ready to go live at any moment, basically. But this is a bit vague sometimes. So let me explain you more or less what is continuous delivery in a simplified way. Always, the trigger for the continuous delivery pipeline is going to be a commit. Let's say that we don't care about what happens before. We're going to build the software. We're going to do some functional testing and performance testing. This part is supposed to be automated. It's kind of easy to automate. Then sometimes we'll have a release gate, and then we'll go to production. Going to production is automated, just like one deployment usually. The release gate used to be a bit more manual phase. If you're able to automate the whole thing, then what you got is called continuous deployment. So let me explain you what was our state, or what is our current state in some different projects right now. This is it, basically. So you have people doing a commit that triggers a build, and then we have deployments to the development and then testing every day. We can do deployments over demand or with one click. Usually it's done nightly. And then usually you cut a release candidate, which can be done on demand with one click. So the thing on the left is what we call usually continuous integration. And then after that one is what we usually try to do in continuous delivery or continuous deployment. It's integration and going to an integrated environment where everybody can see it, of course. Then you have some human weight for doing some QA and making sure that the performance environment is ready, where you will deploy later and then you will test against with one click or on demand and so on. Then you have a release gate, which is human. People that are determining if the software is ready to go live, the timing and so on, if all the tests has been run and so on. And then finally, we go to production where we test also. On demand, one click. As you see, our starting point for doing continuous delivery, it's quite better than some other people, because basically we have a lot of phases that we have automated in one click and can be run over on demand or nightly and everything, but I will show you why that is not quite enough. Basically, we were struggling on some parts, and one of them, that's our company. Basically, we have on-premises data centers, and we have our own software. So we have to build our own cloud somehow. We cannot go to Amazon AWS and so on, so we are having that big restriction. Even if you have automated the deployment of the software, that's not actually enough, because if you have some quality guidelines, you want to go to production, never need to bring anything down because it costs thousands of dollars per minute down. So you need to be super safe. The point is that you're going to have QA testing, you have change management, deciding what is the right schedule and so on. And if it takes days, then it's not worth releasing often, because you cannot be like developing releases 17 times faster than you are able to take it out. So people just get disheartened, and then even though the software is technically ready to go live in 2 hours, still you will be releasing every 2 or 3 weeks. Singletons and some other architecture choices are not often compatible with continuous delivery on 24/7 environments. Basically, it's like you cannot deploy anything that has a single instance of one service, because every time that you're deploying that thing, you're taking an environment down. So when you deploy more often, you're not really fixing anything. You're actually bringing parts of one environment down more often, which can be impacting everything else. Other things that we need also is like, we can have a standard pipeline if each software is compiled in a completely different way. You can have one software that is compiling one way, a different software that is compiling a different way. If not, you go completely crazy. The nightly deployments pattern, it works fine in daily release cycle or something similar. It doesn't really get along with continuous delivery, where you want to be deploying after every single commit. Nightly deployments, usually they can break the environment unless you have a very sound pipeline that is able to test and rollback and so on. You're going to be breaking the environment and nobody's going to be around, which is especially bad if you are a company that has development centers in different time zones. You're breaking the environment and the other persons cannot do anything to fix it, or maybe they are like very limited. And in our case also, the pattern was saying that we need to support both Linux and Windows. We're mostly a Linux shop, but we also have Windows software, and then you cannot be breaking. If you don't do properly for Windows, basically, you can be breaking like the downstream, upstream dependencies for your Linux services, so it doesn't really work very well. So, some do and don'ts that we have learned when creating the pipeline. We wanted to create the pipeline in a way that the parts are useful by themselves. If you create one service that is able to test software, it's nice if you can just leave it on the side. So not only you use it as part of the pipeline, but also like the operations teams can go and then can point it to any environment and then see, yeah, okay, so this microservice is working fine or not. It's part of their debugging process or anything else that they want to do. You need to fail early, so you need to do the pipeline in a way that you want the first stages to be the most common to fail or the quickest. So you need to think how you want to put everything in place. You cannot put the first phase, just building the software and then running a 5 hours test, because you're going to get a lot of time to get feedback. So usually put like the first things that are going to fail first. You need to have highly available environments. In this case, everything that we do is highly available. Development environments, integration environments, performance tests, everything has to be. Every time that we deploy, we cannot allow anything to go down. You cannot be deploying the front end, and then everything's going to be down for a while, because the environment becomes super unstable. If you multiply that one by 500 components changing every day, so you will never have a available environment. Yes, so you need to give it some extra hardware. Basically, you have 2 Blast nodes, or you have 2 Docker containers per server, or something similar. You will need to automate the DB patching, which is a horror due to some resistance sometimes. You need to think. You really need to think what you want to do on the pipeline. You cannot go to complex. You're going to go to simple. You need to think exactly what are your requirements, how many environments you have, and so on. And the final one is a bit painful, but you need to involve every team. You need to do DevOps. You need to involve operations. You will need to involve QA and everybody to make sure that the business even. You need to make sure that everybody's confident with releasing to production anytime without release notes, because nobody's going to give you release notes unless you do a bot for release notes, but nobody will read them. Some things that we learned that you should not do, and the first one is like stop everything and then say, I'm going to do a continuous delivery pipeline. That's going to take you months, if not years. So don't try doing that. Just try to use a continuous improvement philosophy, do components that can be used, and then start creating your pipeline. Don't focus on what the tools gives you, because people are going to say like, oh, I got Jenkins, so I'm going to be installing like 7 plugins for doing whatever. Just think on what you need, because maybe what the tools are giving you is not what you need. You're going to be missing something, and then you're going to have features that you don't want to. Don't get bogged down by ifs. When you start thinking on the continuous delivery pipeline, you will start thinking on super nice theoretical issues, concurrency, timing, and everything, and then it's going to be happening in 0.1% of the cases, if not 0.001, it's just in one technology. So probably just fine if you let the pipeline fail, rather than spending 3 weeks developing a solution for that one. You're working on something that is hardly going to happen, and then you're going to have a lot of more code to maintain and complexity. And make sure that you don't keep extending the pipeline if it's not stable. The main role of the continuous delivery pipeline is making sure that you add confidence into the software lifecycle. So if you keep adding features and you are unable to get up to production, but it fails 50% of the times, you're doing something wrong. You would rather just keep working on making sure that you get a very good rate, even just on the lower environments, before you get to production. We had an internal agreement inside the company, more or less, on how we're going to do everything. We have no functional requirements that are internal. Usually are around design, builds, packaging, operations, and deployment. Basically, for design of applications, we need redundancy or automatic failovers, basically. Redundancy, we can have several nodes of one application, and we can take one down, running the connections properly and so on in the load balancer, without really impacting in, maybe we will impact a bit the performance, but functionally everything is going to be perfectly fine. Or automatic failover, you have two nodes, only one of them is probably like processing a queue or something, but when one of them goes down, another one is going to go and take over. There are many solutions for this one. What you're going to have is like a Hornet queue cluster with just one node or something like that, because then you can never touch a one without having an outage. Builds and packaging, of course, you need to be able to rebuild the software anytime that you want from a tag or anything like that. You need to make sure that what you're building is what goes out. We have prearranged installer format. You can use RPMs, MSIs, or whatever you want. But just make sure that you have everything fine. And no manual tasks necessary. You can install software and then copy files on top. It's going to make your life a lot more complicated. Operations, of course, yeah, you want standard server layout, operating system, you can use Puppet and everything that you want. The application configuration, usually we have always in the same path. So not only I know what is happening on the service, anybody can go into the standard configuration folder to see what are the application properties, how to apply and override and everything. It's very useful for the operations people, basically, and for debugging. Deployment, automatic deployments, atomic deployment and rollbacks. It's very easy to go back and forth on different versions of the application. If you use Docker, then it's trivial. Basically, you just pull an old version of the container. If you use a different system with RPMs and everything, it should also be fine. If you are playing with RG sets, then it just becomes a bit more funny. We also have templated configuration, which is environmental agnostic. So I will show you later, basically, but we have one configuration system where your application gets packaged. It contains a template of the configuration, and it will get deployed it will get replaced those strings during deployment time with the correct value for those environments. It will be database strings, passwords, and so on. So we ensure that we are deploying exactly the same thing to every single environment, including in development environments. So version 1.0 is exactly the same installer in every single environment we go to. We register the service as an OS service, so we just use the standard tools to start, to stop, and so on. Everybody does exactly the same way. And the software interfaces are backwards and forwards compatible. You cannot do continuous delivery if after deploying you break the API and so on. So you need to version the APIs and use the standard methods to achieve this. Since this is a lot of work, we have one concept which we call overlays. So for example, all the Tomcat applications, they will have a Tomcat overlay, which will include init script, which is start, stops, and so on. Will include templated Apache configuration, Tomcat configuration with everything that we want, and so on. So it's very easy just to import a lot of files, and then your services just work. You just drop some code, drop the overlay inside, and then you got like all the files that you need to have your service work with these patterns. Some good things that we have with this one, aside of the possibility of doing continuous deliveries, like for people to change SIM is like super easy, or checking a different product, you just check out, you know how it's built, you know why it's going to generate, you know how to deploy it into any machine. super easy to support when you have like hundreds of components. And of course, yeah, you can do CD. So once explained this, let me try to show you what we see as a continuous delivery pipeline, the process. Our continuous delivery pipeline needs to coexist with non-continuous delivery components. In case you have hundreds like us, you will have people working at different paces, so it gets very fun. Anyways, let me show you. From our point of view, what a developer usually is going to commit inside their products is going to be codes, any code change, and then tests. Sorry. Our tests look like this, basically. We have one framework where we use Gherkin as a base language, and people write the user stories in natural language. This is done in a way so the business analyst basically can just pass a user story in natural language, and then people can just copy and paste as a test for that user story. They usually use like some verbs or primitives are already defined, and if they are not, they just need to write the small bits. So basically, when say given that I navigate to the login page, we have verbs for navigating to the login page and so on. So people do the code and tests, and basically, usually they're going to be working in one branch for the user story that they're working right now on. You commit into the code repository, and that triggers a build for that specific branch. What we do with this build specifically is we deploy to one environment that we call tdev. In this environment, basically, what we get is your service with mock dependencies. This is achieved basically using Docker Compose. We haven't yet this really working yet, so this is just a concept. You will see this one because it was exactly the same thing that Eve was commenting a while ago. So basically, you have the service with your mock dependencies, where what we do is just launching some functional testing. So we're going to be hitting all the different APIs in isolation. What we get with this is being able to test your service with the mock dependencies, be able to make sure that you haven't broken any past functionality. We'll test a new user story, so make sure that you really do what the user story is asking from you. And if everything is working fine, we will merge back to the main line. It's like basically this phase tries to prove if the quality is good enough to share with other developers. Evidently, if you break the regression pack, your branch build should fail, it will go red, and then the developer has to fix it. It will never get merged into the main line. If it's good enough, then the pipeline can continue. This is basically a merging process, just a gatekeeper to make sure that you never break the main line or the trunk. So basically, what we do at this point is once we know that the software is working functionally, it's merged automatically into the main line in the code repository, which triggers the regular continuous delivery pipeline. We're going to branch you, just to have a branch in case. We're going to tag the software, and then we're going to build a release candidate. We call them release candidates. We don't even include the RC. It's 1.0, 1.1, 1.2, or anything like that. Exactly at this step, we build the artifact that is going to go to production if everything goes fine. It's as early as this. You can generate whatever you want. You can use RPM, dev, semi-site, RG sets, everything. Basically, what we do is like to avoid rebuilding the software many times because your continuous delivery pipeline needs to be fast. You should be delivering to production ideally in a matter of minutes or hours, maybe, depending how long you take to do the whole software, how complex it is. We just got as early as possible to avoid building twice or any other thing. Basically, from the development environment, finally have our artifact. We deploy it into our integrated development environment. This is a development environment usually where one developer tests locally, usually they will point to these shared resources. This is one environment that is always going to have. It's just going to be app, it's going to have databases, it's going to have everything. We just deploy there and do functional testing. smoke in one smoke node first, and then later on in the whole pool. Usually when we deploy, we just take one of the two nodes out or one of the end nodes out. We deploy into the one, we run all the functional tests against the one, and then if it's fine, we will just deploy to the whole pool and then run all the tests in the whole pool. And we have exactly the same thing. One environment that is a bit more stable that will have like the developers pointing to it from their own machines, which is called an integration environment. We do exactly the same thing, functional testing, smoke, and live. On parallel, because this takes a while, we have a pdev environment, which is exactly as a tdev environment. We just put your service with all the mock dependencies around. Maybe we just put like mocks of the different APIs that you used to talk to, but we can also like put like a blank database with some seed data, so you can also have like some data and so on. Same as before, we just use Docker Composer, so you can do like a very easy, you can set up the environment quite easier. And we just run performance testing. This is baseline performance testing, so basically what you do is like you just compare how was the performance to the previous version. The scripts are usually form part of your own products and so on, so they come as part of your deliverable. If both of them are fine, then we clear this one. Basically, we run pdev at the same time as the development and integration environment, just because it will take a while longer, just to make sure that everything is fine. Just as an declaration, some teams want to have, after the development and integration phases, they want to have a small manual phase for QA. This is also part of the adaptation to continuous delivery. Maybe you are not confident that the tests that you're running afterwards cover exactly all the functionality that you want, so you can have a pipeline that actually at that point just waits for a manual intervention for something to click actually through the website or do anything similar, and then checking that everything is working fine. You will have to do compromises if you introduce continuous delivery inside a product stream. What is the point of all these phases? All these deployments, all the performance testing, and all this functional testing is if the quality is good enough to undergo a realistic performance test. Because we have one low test environment with this a replica of production, similar hardware and everything, so it costs a fortune, just in electricity bill. So basically, we need to make sure that before we hit this environment, we make sure that everything is working fine, because if not, it's a disaster, hours lost, and so on. We need to optimize the utilization. So the way that we do is like in the previous phase, when everything is passing, all of them get into one queue. Basically, we start queuing all the services are ready to go to the performance test, because the issue is that maybe there is a performance test already running, simulating a very big event, Christmas, Super Bowl, something funky, which takes many hours basically to happen. So we don't want to keep deploying because it can change the performance. That will probably come in a later phase, a 24/7, where we can deploy during an event. Anyways, in this case, it's like the service 1 is gonna get into the queue, version 1.0. So we have an environment is ready to be deployed into gate. Everything will get on the other side of the gate. Service 2, 5.3 comes here. Service 3, 2.5 comes here. So everything starts getting queued because all the different pipelines for all different products are like throwing all of them here. Then maybe later service 1 comes to version 1.1. So at this point, usually what we do is that we just invalidate the 1.0. So we don't want 1.0. We already have 1.1 in the queue. And whenever the gate is out, we just deploy all these 3 components into the performance test environment. It's like the previous test finished. Let's get ready for the next phase. Then we just launch performance tests. It can be tens of thousands of concurrent users doing all kind of funky stuff on the different websites, hitting APIs, and so on. And then we just do an assessment. You see here that we had 3 different services. It can be like dozens of services. When you have a performance test, you can only say if everything went fine or if everything went wrong. You cannot really say like, oh, the service A went fine and the service C went wrong. You cannot really say that one because the bottlenecks are different and so on. So that's what you need to have the pdev before. So if you tested all the performance of the different components, it's better or the same than the previous one, and then here you get a problem, then there is something really wrong. will just be like the environment broken anyway. The question of this load test environment is like, can we survive 3 to 5 times the projected peak load of next year? So basically, we just need to see what is the peak load and so on. It's just basically the nature of the business. We have a business where we have peak loads a few times per year. This is not one API that today has 1,000 requests and then tomorrow has 1.1K and then it has 1.2K. We don't grow linearly. We have like huge peaks every year. So we need to run this kind of performance testing. Super important. Let's say that up to here, it will be the end of the continuous delivery. Once you have tested everything is functionally fine and then performance is fine, you should be ready to go to production anytime. We have a bonus that we're working on basically because the customers don't get any value until the software is live. Be it active or not, the software needs to be live before people can start getting any value. So we have the pipeline raising pre-approved requests for change, which is basically for change management. Software version, user stories, all the phases results that went through, and so on. So we did everything. And then we just have to deploy to production. And then we just run the functional test, the smoke alive. And this is what is called continuous deployment. Let me show you exactly, because here I've been saying like we deploy to development, we deploy to integration, and so on. Let me show you like a bit better situation on how we actually deploy software. This is software, in this case, continuously redundant, or a cluster of services that are active failover. So when one of them goes down, the other ones are going to notice that they need to take over. In that case, it's transparent to us. Basically, the first thing that you should be doing is you just run a smoke test on the current service before you try to deploy anything, because everything gets super confusing. Imagine that you're doing a deployment and then you run a smoke test at the end and it fails, and then you do a rollback and then you run a smoke test and then it fails again. You say, oh, what broke? Is the test or is the service? I didn't do the rollback properly. So what you always do is like first you run the smoke test to make sure that your smoke test pack is working. There is nothing wrong with the environment that is going to really screw you. So once we have run the load test, what we do is we just one random server, we just select the one as a smoke test server and we just take it out of the pool. And then we just deploy the next version, 2.0, into that server. And we run a smoke test over that server. In our case, we're having our own smoke test pools into the load balancer and everything to make sure that if you have fancy rules or anything in the load balancer doing changes, it also works. Once you run the smoke test, if everything is fine, you take the node out. You see this, right? You need to make sure that you don't break backwards compatibility. The APIs are well versioned and everything if you break anything, because you need to live with mixed versions. You need to. Same thing, we just mark the second node out. Well, usually what we do here, because I only have represented 3, then you can do the rest of the service in chunks, usually. You can depend on how much performance, margin you have on the performance. Maybe you can take 30% of the servers out, or you can take 50%, depending on how much. We usually take half, so we deploy the second one, and that is it. Just marking one server out, upgrading it, and then at the end, we just run a smoke test and a live test in the whole thing to make sure that everything is working fine. So you can have an overall view of the whole process. So the code at test, usually we put into the code repository in the branch. It goes to one environment, which we call tdev, where we test functionally if everything is fine to be merged into the main line. If everything is fine, we merge back into the main line. We build the release candidate. We put the artifact into the artifact repository. And then at the same time, we start deploying into the development environment, integrated development environment, and the performance development environment. We run functional tests and performance tests at the same time, since the performance test is going to take a bit longer, or would you want to maximize it so you can throw a very nice number of requests against the APIs. We go to the integration environments, you run the functional tests, and then in the end we just get the results of both. If both of them are a pass, we enqueue this one before we go into the load test environment, where we run the performance test. If everything is fine, request for change to go live, basically, just for documentation purposes as part of change management on ITIL and so on. And then we deploy to production. We run a functional test. And this pattern also works for Windows services. There is nothing really fancy going on there. So, before I show you like the products have code and test, this is why it looks like a product for us usually. You have the code, you have the functional tests, which are the different user stories that you get put in there as you've been doing there. In our case, we have the ability to tag them as these are smoke tests, these are live tests, these are regression tests, and so on. So you can divide them in parts, so you don't always have to run all of them. We have the component performance test, which is the one that you run in the PDEV environment, where you say, hit this API 1,000 times, hit this other API, whatever, and then just the framework should like compile the mean and the maximum and the minimum and so on, and then check if they are better than the previous version or not. You have your own mock. You need to provide your own mock. So when you are not the service being deployed, but you are being deployed as a dependency of other, they can also use you. And then we have a Docker compose that is going to deploy you into a Docker container, and then it's going to call all the mocks of all your dependencies and also deploy them. So you can have TDEV and PDEV as environments. So this is the theoretical part, again, with a few more details. Let me show you the tools that we are using for this. Some of the common ones. So for orchestrating the pipeline, all this flow, and for doing software builds, we use Bamboo. This is Jenkins, but a bit nicer, maybe. For source code, we have people using Subversion or Git, Bitbucket in this case, also an annihilation products. For software packaging and publishing, we use Maven. It's just a wrapper sometimes. If you have Windows software, you just be calling a bad file, and then it's not so bad. For binary repositories, we use Nexus OSS, open source, very good. And then Artifactory Pro for some Docker and pip and everything, but we're actually getting this out because it's not so nice as it looked like. I have some people laughing on the side. Yeah. For code coverage, Sonar, open source version, it just works like perfectly fine. Server configurations is Puppet mostly. For server configuration, Puppet. For software configuration, I will show you later, we have our own service called ProWS. If you have read the continuous delivery book by Martin Fowler, like an old one, kind of, they propose Escape. It was missing a few features, so we have done our own one. I will show that one later. So yes, so you have one idea. This is how Bamboo looks for us, and this is not even like the whole pipeline. It's not really very nice. Okay, sorry. It's just a resolution. So in the left side, we have like a full pipeline where you can see like all the different phases that the software has been going through. From deploying to the different environments and so on, they go green or red, so you can see everything once. So basically, Bamboo is the one in charge of bringing the code change up to production. We just have a relation Bamboo with a ton of agents, mostly running just bash scripts, which are the one calling all the services I will show you later. Usually Bamboo doesn't do like anything special. We have everything done in different components, the one launching the test and the one deployment and so on, which I will show you later. So it's like super lightweight on Bamboo. We chose Bamboo in part because we have the rest of the Alation stack. So this CD pipeline kicks in, and then you can see on the actual Jira tickets for the user stories, a Bamboo plan has kicked in, and then it's in progress, and then you can go from there into the actual pipeline. So it's very easy like to track it. When our continuous delivery goes red for some reason, I guess you cannot see the one, but actually here this part went red. The regression on the linked environment. The thing that we're doing is like with our test launching tool, it's just generating JUnit, so we can feed the data back to Bamboo, and then the users can see the errors actually there. So you see there that we skipped 259 tests. We had 5 new failures, and then 109 since the previous execution, which is a pretty bad broken pipeline. And you can see match there either, bad one. But basically there you get like the results actually of the test. So since we generate JUnit reports, you feed that one into your continuous integration tool or pipeline orchestration, and then you can see actually all the different results. We're just making the best use that we have of the tools. This is another component that we have. Holy shit, okay, that's completely unreadable. So this is what we did that replaces escape, and this is like one of the cornerstone, if not the cornerstone of the whole thing. So this is a service that holds all the inventory of all our environments. So there we have defined all the different environments that we have, all the development environments and so on. So he knows what's the domain for each environment and so on. So when one server says, I'm the server with the hostname X, he can tell it, you are the server, you are on this environment, and this is the configuration for this environment. So there we have a configuration key store, which is the one that is able to give everybody like the correct values. It has default values, and you can use patterns into it. I want you to return the URI to the database is mysql.environment.domain or something like that. So you can just auto-build to be completely agnostic. Even if you define new environments, you don't need to define like all different kits. Or you can have overrides per environment and host, which can be, for example, passwords and so on, because you don't want the passwords to follow a pattern, or you shouldn't. Also, having one service like this one has a very good benefit, and then it's like we have a centralized inventory of all the products with all the Subversion or Git paths and so on, and all the different tools. Jira, you want to raise a change? What is the name of the product? You can just query an APA and then get like all the different names of all the products and so on. Inside this model, a product for us is a source code, master, trunk, or something. We can generate no service if you're a library, so you just generate things that are going to be used by other people, or you can generate several services, which are these services which are deployed into the different environments. We just store like artifact coordinates, what is the URLs to do health checks and so on. The services can have different versions per host and environment, and the services can have one or many load balancer pools. So basically here we have the whole data model that every other tool uses for it. As you can see here, well, here you see like a list of endpoints. Sorry if you're gonna read this once, basically. But what we're using behind here is Django and Celery. We have a full REST API with pagination and extensive filtering options. We have caching layers with partial invalidation and so on. And it just can handle hundreds of requests per second on just 4-6 cores. The next tool I want to show you is Test Launcher, basically. So we have one of these per each data center, and it tells you which tests are running on each data center. We have here like a current activity on top, where you can see like all the progress of the different tests. Below, if you have any test RQ, because maybe we would have enough Selenium agents. And then on the side, you can see all the tests that we have finished with the different names and versions and so on. Software is Django, RabbitMQ, Celery, and a Selenium cluster, basically. When you click in, well, you can request arbitrary test, as you can see there. So you will have a phase, environment, and basically that's it. You just select the product, which environment you want to do, and which kind of test you want to run. If you want to run smoke, regression, or anything else, you launch the test, and that's it. You don't need any knowledge about QA. In the end, it's just going to give you, it's going to give you like the progress. So you can see the one is basically downloading the source code and then running Maven integration tests, so on, with a few parameters. By the way, this tool is able to launch tests by just doing a checkout of the source code and then running, telling what is their public URL. You can run that one locally. The developers can run those ones locally, pointed to their own machine, and it does exactly the same thing as the tool. So you can run full regression pack against your own machine at the same time that you are developing something. Which is super simple. Detailed process with real-time logs, basically. When it finishes, it generates the results. They can be seen online here. The load is a zips, and then it has a super easy button to relaunch tests. Sorry, you're gonna read that one. You will see here how we we pass like two scenarios. Both of them are written in natural language, talking about like, as a customer service representative, I want to see blah, blah, blah. I want to click here and then see whatever. And actually, you can spend them, and then you can see exactly how many tests were run, and then you stand them, and then you see exactly which API queries well done, and exactly what was the data returned back to the API, and so on. So if something passes, you can see why it passed. Something fails, you can see why it failed. Another service that we have, it's called Deploy WS. This is the orchestration service I was showing before, like taking notes out, deploying into them, and so on. So right now, what it's orchestrating is the hardware load balancers, making nodes in and out, draining connections, and so on. It does the calls to the test launcher for all the different functional tests, and does deployments into the actual servers. Is Django plus some REST sub libraries for the load balancers that then use Fabric to connect to the servers, basically. This is like the overview. It's nothing fancy. It's not the best UI in the world, but basically this is a pass deployment. On the top, we have like a small overview showing exactly like the small phases that we pass, the orchestrator logs, so you can see exactly the timeline when everything was deployed, and so on, and was like the different results that were done. The host logs, so you can see the logs of the servers, and then on the right side, you have links to the different tests that were run with the test launcher tool, so you can jump into them directly. If something fails, you will see two red boxes on the right, so two of them failed. It will just automatically do a rollback and then run again all the tests after doing the rollback. And in this case, they passed. So we have been able to roll back without really affecting anything. It doesn't have a very complex API, as you can see there. The main endpoint is called deploys, and it just needs like 3 parameters. The service, the environment, and which version you want to deploy. It has a full REST API. We have another component, which is called Unattended Test Launcher. Sorry for that one again. Basically, it has all the different test executions that they have been done. We use usually WebLoad, which is a super expensive test tool. Very cool. Django application. And it has a full REST API. This one also has the ability to enqueue deployments until the current load test is over, or when somebody calls it manually. It generates some fancy reports telling you what are the load profiles. It automatically tells you if it looks fine to go live or not. And it also generates calls, some other utilities that we have to generate OpenNMS, aggregated reports, and so on. It will compare the metrics against the NFRs. Code coverage plugin. So I told you we were using Sonar. So through the pipeline, I didn't specify there, but we not only run like smoke tests and live tests and so on. We also run regression tests, and we run E2E on different phases. And we wanted to capture everything under Sonars to have the code coverage. Exactly how many pieces of code that we are covering, if we are covering the positive if and the negative if and so on. So we just developed like a small extension to Sonar where we can post all the different phases that we run. And so it can calculate like the overall coverage, but also it can tell you your smoke tests are covering 14%. And your integration tests are covering whatever or not. So we can see exactly, so we can see like the overlap of the tests to make sure that we are running the most useful and so on. Other software that we use a lot. So we have CD pipeline scripts, all these scripts calling all different services and then aggregated the results, calling another one and so on. We have AuditWS, which is also a cornerstone for us. So it's like all the different services that we have are sending usually events into one audited centralized system, so we can get any statistics of anything that is going on. So we see all deployments that happen at any point in time and why. We can have timings, and then you can have everything. We have Conf Overlay, which is, as I mentioned, one reusable component, so the team include inside their software, which is the one that is called during every deployment to replace the templated configuration with the final values. We have Global Tracing Framework, which I only put one line there, but it's huge. So we have a fork of JMeter with tons of features. We have extended that one, and we can do a lot more cool features. RedChat, a super REST API to Jabber one. It also supports Jira webhook calls. We have a mocking framework. So basically, we got war mock, and then we just made it work. Given a Swagger definition on one API, you can define scenarios. So when you define the one, you get both the API documentation and you get a working mock for your product. So you get like two in one. We added a few additional features like cookie support, be able to return invalid HTTP responses like malform, forward requests to the actual backend in case you're feeling lazy today and then you don't want to implement something, so you just point to the MDev environment and something like that. And dynamic responses using elements from the request or even function generators like random numbers and so on. And then we have a funky plugin for service transition just to be able to raise pre-approved changes. Well, it does a lot more things. Basically, we have pre-approved one-click changes, and then we have ticket-based approvals and so on. We have change management meetings anymore, basically. One thing I want to tell you is there is a very nice talk in Expo QA in Madrid on June 8th by our head of performance, in case you want to go there. He will show very well of all the performance testing in continuous delivery, because I just passed like over the top. In case you want to go June 8th, it's going to be around 2 hours. They're going to show a lot of stuff. So, using all different tools that we have, very briefly. One thing I want to tell you is that we have the plans of open sourcing all of this. So you should keep an eye on GitHub, the workshop labs. We want to open all of them so you can start using them. There will be some more usually. The first one that you want to use probably is going to be ProWS or something like that. So that's a cornerstone where all the data into your application sits, and then you can start using the rest. You can use deploy AWS and so on. When we get them out, we'll show exactly what are the dependencies with them, so you can set them up. And basically here is just wanted to say a few thanks to all the different guys working on all the different things that we have. We have engineering teams, delivery services, QA automation, and performance and service transition. Just so you have one idea of how many people is involved. It takes a lot of work of many different people. And say this. Well, yeah, of course, we are hiring. We're always looking for people. This is continuous delivery. We really love it. So let me know if you have any questions. Yes.
Hello.
Hi.
Okay. This TDev and PDev, these environments are static or are dynamic? I mean, you do a commit, you create a new environment per commit, or is a permanent?
Yes, you should be creating a new environment per commit. You can either just have everything with Docker. You can have like the physical machine, just Docker, and then when it stops, you stop everything, and then it's gone. Yes.
And the other one?
The other ones we have, they are static. They exist statically. Eventually, we want to have several. We want to have dynamic, but right now we have the capability. We are on premises, so we're building our own cloud. I wish I had Amazon WS, but we don't. Yeah.
Okay, and you have in the query,
yes.
When you two versions of same service arrive, this means that there is more than one commit.
Yes.
If something is wrong, how do you find the responsible of the breaking of the pipeline?
That's why we have super smart developers. It's gonna be, yeah. At this point, after we have been running, I mean, it's like functionally, it's gonna be weird if it's going wrong. Probably it could be like the weakest component. So it's like if you're doing all the services like this and you're not doing the database, so probably your database in the performance test environment is broken. It takes a while. I mean, you can do something so simple as removing the last commit from the main line and then see if that one passes, and then you have some way to see the one. But usually it's going to be down to the environment. That's why we are testing in all different phases before we get there. You need to test everything in isolation.
Okay.
Well, thank you.
Quick question.
Do you make code reviews, and where are those in that pipeline?
Yes. So one thing that you can do is put your code review step at the end of TDEV. So you run TDEV, everything is functionally fine, and then you raise a code review. You can have a manual step until you don't pass a code review, we don't merge into the main line. So that is like your gatekeeper phase. So you can extend this as much as you want. I got like some requests from some teams of QA. It's like, even before you merge, I just want to know exactly where it is, so I can also like launch a few extra QA. It depends on your components, but there you can put like several manual phases. Bamboo supports one, I guess Jenkins and everybody else also does. So until everybody says like yes, it just actually gets merged into the main line.
Thank you.
Welcome.
Well, thank you, Juan Jose, for that excellent speech. And
Okay.
yeah, it's good to see it laid out like that.
Okay.
Thank you very much.